and welcome to my 6th video of the series about population, and today we're going to be answering some more exam questions. So these questions again are taken from the AQA biology course, and they're taken from the Unit 4 paper. And so if we look at the first question, woods can be coppiced to provide continuous supply of useful logs and poles. Coppicing involves cutting down some trees in a wood to leave stumps. New shoots grow from the stumps. After about 15 years these trees can be coppiced again. Because coppicing produces wood with patches of light and shade, diversity of plants and animals in a coppiced wood is high. Ecologists investigated the effect of coppicing on the flowering of wild daffodils growing in the wood in Cumbria. Some areas of the wood were coppiced and some areas were not. The graph shows the results from this investigation. And so what you've got, the hash line is not coppiced, so no cutting down of trees, and the full line shows it being coppiced. And you can clearly see here there's a spike with the coppiced version. You could collect data from coppiced plots by using quadrats. Describe how you would place the quadrats at random. So this is a standard question to do with quadrats. And so what you would do is you'd grid the area from a specified start point, and then you'd randomly generate some coordinates off it by using a computer, a random number generator, pulling numbers out of a hat, anything of that nature. The next question asks, describe how you would decide the number of quadrats used in order to collect representative data. So there are several possibilities. This question is worth 3 marks, but there are several things which you could say. One of them is to ensure reliability. Anything to do with repeats, you should be mentioned in terms of reliability. That would be 1 mark. Another simple one to say is enough to do a statistical test. You don't even need to name what the stat test is, but simply mentioning that. And then, when using more quadrats, fails to alter the findings. And so, essentially, when you find, or when you've plotted the data, by adding more data, it doesn't have an overall effect or have a marked effect on your results overall. That could possibly be another thing you could say. And so, any 2 from 3. And so those previous 2 questions are pretty stock questions you'd expect on any population test. This one is more specific to the data you're given. So, members of the public visit this wood to see wild daffodils in flower. Explain how the information in the graph could help the owners to manage the wood so there were many wild daffodils in flower every year. So if you actually look at the data that it's given you, when it's been coppiced, there tends to be a spike in the number of daffodils. When it's not coppiced, the numbers tend to stay quite low. And so you should be able to identify where the peak is, and so the peak is at every 5 years. Now the question specifically asks, so that there were many wild daffodils in flower, every year. And so what you want is daffodils within the wood every year. And so to get high numbers of daffodils, you're going to have to coppice, and you're going to have to coppice every 5 years. So that would be the first mark. Now, it says in flower every year, and so what you need is a system whereby, regardless of what year it is, people should be able to come and visit and see daffodils. Now, the problem is if you coppice the whole lot, what you'll end up doing is having no daffodils for 3 to 4 years. And so what you need to do is coppice in different parts of the wood every year, and therefore that's the second mark. On the final question, the ecologist analysed the relationship between the number of daffodils in flower and the whole wood, and the data collected from nearby weather station for the previous year. They used a Spearman's rank correlation test as data shows their results. The ecologist concluded that a wet, cool summer produces good flowering the following spring. Do you support this conclusion? Use the data in the table to explain your answer. And so what it said, the ecologist said that when it was wet and it had a cool summer, you normally got good flowering plants. Now if you look at the data here, if we look at this first conclusion here, so wet, so with this, that will be related to the top 2, so the total rainfall. And what you'll notice here is there's a positive correlation, and so they're 0.65 and 0.74. And so you could say, by analysing it, there's a positive correlation between more rain and between the flowering plants. So wet corresponds to these top 2 results here. Now the cool summer conditions, your mean monthly temperature, these here, that shows a negative correlation. So that basically means the hotter it is, the more they grow. And so again, you could reference that. So with the cool and these 2 values here, because it's a negative correlation, so that means the cooler it is, the more they grow. and so that would obviously agree with the conclusion. And the one final thing that you've got here, you've got this column here that talks about statistical significance, and therefore you could say that all of the results show significance, and therefore this would back up the findings. Oh, another thing to note down there is because they're significant, it would be unlikely that it's not just down to chance, and therefore there's other factors involved, specifically the rainfall and the temperature.